Welcome back to our YouTube channel. In today's video, we will solve an interesting problem from coding interviews. It's called Move Zeros. We will go step by step, starting from a basic approach and optimizing it to the best solution. Stick around till the end and let's dive in it. The problem is simple but very common in coding interviews. We are given an integer array and our task is to move all zeros to the end of the array while maintaining the relative order of the non-zero elements. The solution must be in place, meaning we cannot use extra space to create another array. For example, if the input is 0, 1, 0, 3, 12, the output should be 1, 3, 12, 0 and 0. And if the input is only 0, then our output will be 0. Let's move towards the constraints. We have only two constraints. The first is the array length is between 1 to 10 to the power 4, and the second constraint is each element lies between minus 2 to the power 31 and 2 to the power 31 minus 1. Let's begin with the simplest solution using a temporary array. This solution will be completed in 3 steps. In first step, we will traverse the array and copy all non-zero elements into a new array. In second step, we will append zeros to the end. And in third step, we will copy everything back to the original array. Now suppose we have input given an array nums with elements 0, 1, 0, 3 and 12. Now we will create another temporary array of the same length. And now we will append all the non-zero elements in the same order. That is, we will first get 1 from here and will append it at the starting index. Then we will get 3. We will append this 3 here. Then we will get 12. After appending the 12, this original array is finished. Now we will fill the remaining 2 places of this array with zeros. So this is how we can complete this solution using this basic approach. Now this is the code for this basic approach, and the time complexity of this code is big O of n. The space complexity is also big O of n. The problem with this approach is that it requires us to create an extra array which will need the extra space. But in our problem, we were asked to solve this in place, which means we are not allowed to use any extra space. So let's try to optimize this space complexity in our optimal solution. Approach. Suppose we have an input array given with elements 0, 1, 3, 0 and 12. Now we will use 2 pointers approach in this our optimal approach solution. Suppose we have pointers p and q initialized over the first index, that is 0th index. This is p pointer and this is q pointer. Now we will check if the value at q is non-zero, then we will send that value to p. Otherwise we will simply advance this q pointer. Here we have the value at q is 0, so we will simply advance this pointer. The q will move from here to here. This is q now. Now the value at q is 1, which is non-zero, so we will send this value to the p. So the value now over the p pointer will become 1, and we will advance this pointer p. P will come here now. The work of q is also done, so we will advance now q. Q will come here. Check if the value is non-zero. Here we have 3, so we will send this value to the p pointer. P is here, so these 3 will come here. Advance this p pointer. The work of q is also done. Advance this. The value at q pointer is 0, so leave it and advance the q pointer. Now the value at q pointer is 12, which is non-zero. Send this value to the p pointer. P is here. This 12 will come at this index p. Now we can see our array has finished for q pointer, but our p pointer is still at this place here. So what we will do now, we will add zeros for the all remaining places for p pointer. Suppose p is here, there are two values left, so we will add zeros for these values. Now this is how we can move our zeros in the last, maintaining the index of the non-zero elements. And we can see we have got our answer. Let's see the working of this code of optimal approach. In this code, if we see this for loop, then in this for loop, whenever we encounter a non-zero element, we place it at position p and increment p. This ensures that all non-zero elements are moved to the front of the array in the same order as they appeared. After this loop, p points to the index where zeros need to be added. We simply fill all the remaining indices with 0 using this while loop. The time complexity of this code is big O of n and the space complexity is big O of 1. We can see that we have optimized the space complexity from big O of n to big O of 1.